In this video, we're going to show you how to add a second oscillator to your Werkstatt. For this project, you'll need two 10K potentiometers, a breadboard, one 6.8K resistor, wire cutters, a Phillips head screwdriver, and jumper cables. Our first step is to unplug the Werkstatt. Then, using the Phillips head screwdriver, we'll remove the top 4 screws. Inside the PCB, there will be screws holding the board to the chassis. These are the screws that you'll need to get ground off of. Simply strip one end of a jumper cable, wrap it around the ground screw, and tighten. You can now close the Werkstatt. Now we can plug our Werkstatt back in. For our second oscillator, we'll actually be using our LFO. To ensure that our LFO is audible, we actually need to patch the VCF out and the LFO out. This seems counterintuitive, but it actually works. I'm going to be doing this through one of our 10K potentiometers to allow me a level of attenuation. Take your 10K potentiometer and place it in your breadboard. Then, using a jumper cable, run from the VCF out into one of the far legs of the potentiometer, and from the center pin of the potentiometer, run a cable back to the LFO out. At this point, you should be able to hear the LFO if the frequency is in the audible range. The potentiometer acts as an attenuator for the LFO signal. You'll notice that the LFO is stuck to one tone. To make our LFO playable, we'll need to use the KB/CV out. This sends out a different voltage depending on the note played. Using a jumper cable, run a line from the KB/CV out. Next, plug in your second 10K potentiometer. Run the KB/CV out into one of the far legs of the potentiometer. Next, plug your 6.8K resistor into the middle leg of the potentiometer. Now, run your ground wire into the opposite leg of that potentiometer. This potentiometer will allow us to tune our LFO to be in sync with the KB/CV out. Now we're ready to run a line from the 6.8K resistor into the LFO in. Now when we play our Werkstatt, you'll hear that the LFO changes pitch similarly to our VCO. However, it's not a perfect octave. This is where we'll need to use our tuning potentiometer. And now you have a second oscillator that is completely controlled by your keyboard. Since we're using the LFO as a secondary oscillator, that negates its use for any other control voltage purpose. Also, since we're patching the LFO out into the VCF out, we're actually bypassing the filter altogether. You can hear that if I change the cutoff frequency of our VCF, only the VCO is affected. If you decide you want easier access to this feature, we've provided 3D printer files for an enclosure online. These will fit your breadboard perfectly. By using our keyboard control voltage out and a few discrete components, we're able to greatly increase the capabilities of our LFO and turn it into a second audible oscillator. All parts lists, fritzing models, and 3D printer files are available online at werkstattworkshop.com.